talk about an application on how to model debris and mud flows. This application was developed specifically for Cameron Highlands in Malaysia. What we're going to do today is take a rainfall station and correlate it with some known events and determine the model parameters. These parameters allow you to define the limits on when a rainfall event is considered to be triggering a mud flow. Here on the main screen, we have the different steps to develop a model. It can be used on any web browser, but you have to be online since the application uses a lot of online services. On the screen, we start from the left and we make our way to the right. If there is no station to model, some of the buttons will be disabled. However, if you are halfway through, you can still go back and model a new station. Let me bring you to the links that these buttons can take you. At the top of the page, there is a navigation bar. It's basically a black bar at the top. The first link is called New Model. This is to start any new models, and you can do this at any time. Next is Home. This brings you to the home page. About takes you to a brief explanation of the owner of the application. And the last link is Contacts. It tells you who to contact if you have any questions. Click on the link called Select. A list of available stations appear. The list on the left are stations for Cameron Highlands, followed by a Google map of the listed stations. You can perform any action as you would with any Google map. If you click on a tag, you can zoom in. The list on the left shows all the rainfall stations in Cameron Highlands and the surrounding areas. The list on the right are other stations outside of Cameron Highlands. These are not on the map. In my example, we select JPS Mardi at Tanah Rata. A blue box appears which gives you information on rainfall data at the station. This is called the Sessions box. It shows the date of when the data started. You will notice that the other links are now enabled, which means that you can analyze the data, correlate the rainfall data to the model, and simulate the model. By default, the rainfall analysis starts at the first year. The way the page is organized is showing daily rainfall for every day of the year. For example, if you look at August and 7th of August, you'll see 50.3, meaning that the rainfall was 50.3 millimeter. At the bottom three rows, the first is maximum daily, the highest daily rainfall recorded for that month. The next row is total, that is the total reading for that month. The last row says wet days, which is the number of days that rainfall occurred. Similarly, the last column of the bottom three rows, the first number shows the maximum daily for the year, and the next number after that is the total rainfall for the year, and the last row for the column shows the total number of wet days for the year. In the Sessions box, there is additional information. It allows you to jump to any year. We click on 2014. Now let's look at the end of the month. If we select November, it'll take us to a new page, and this page displays the rain graph for the month of November. In the Sessions box, it will display the appropriate information. Maximum rain, it shows 116 millimeters. The total was 367.8 millimeter, and wet days was a number of 24 days. So you can do that for any particular month for any year. If you're happy with the rainfall analysis, you can go back home by clicking on Home in the navigation bar. Now that you've analyzed the rainfall, let's do the modeling. Click on the Define button. What you see here is that the session box displays new information. On the right is a graph of the rainfall events and the known occurrence of debris and mud flow events. The vertical axis shows the intensity of rainfall per hour, and on the horizontal axis is the working rain. The working rain is defined as the half-life of consecutive rain for 14 days. This means that the value of the first 24 hours is kept intact. The next 24 hours, 50% is used. The rest is runoff and evaporation. The subsequent previous 24 hours is half of half, which is 0.25. Each dot on the chart is a rainfall event. When it rains, that particular event is represented by a dot. If that particular rainfall event causes a known debris and mud flow, it will appear as a slightly bigger dot. If you hover over the red dot, information of its value appears. The first value was working rain in the ground. The second value indicates the intensity per hour for that particular event. Now let's look at the lines. The blue line represents the critical line. The critical line is defined as the cutoff where any rain event will result in a mud flow or not. Rainfall events that appear at the right of the line is supposedly causing a debris and mud flow event. Events below the critical line will not create any mud flow events. You can move these lines. Now let me introduce you to the orange and red lines. The orange vertical line is the warning line. If you track the current rainfall and it crosses over this line, you have to issue a warning to the community. Thus, it's called the warning line. The other is the red line, and it is called the evacuation line. Any event crossing the line tells communities to evacuate. You can move these two lines. The lines can be moved if you define it in the sessions box. In the session box, you will see the station information followed by the parameter that defines your model. And below that is a list of links for what you want to do in this next session. The first parameter is trigger, and the default value is 50 millimeters. What it means is that it is the rainfall event that you select from the rainfall data. But you can change its value. When a rainfall event exceeds 50 millimeters, you want it placed in the graph. The next two parameters are CL intensity and CL working. CL means critical line. CL intensity is the criteria line intersecting the vertical axis. So in this case, we see CL intensity as being 100 millimeters per hour. CL working is the critical line intersecting the horizontal axis. What you see here are the default values, which is 110 millimeter. You'll be able to change it. So now let's change it to 80 millimeters. Then you will notice that the critical line now intersects the intensity rain at 80. You can confirm this by hovering your mouse at the intersect. You can do the same for CL working. The next two parameters are the warning and evacuation lines as represented by the orange and red lines. The default numbers in these two boxes are actually the intensity rainfall against the critical line and shown by the orange line. So looking at the warning line, the value is 63.08. Let's make some changes here and make the warning line 72 and the evacuation line 50. The next line, or the next parameter, is called working options. It is the half-life method that is being applied to the working rainfall. 0.25 is the half-life working rainfall that starts at 0.25, and the other one starts at 0.5. Lastly, the last box says session name. To save your parameters that you have made just now, you can rename your session. So in this example, we shall call it Zach. To activate any of the parameters, click Update. Finally, at the bottom of the session box, there are some options to continue. The first one says Restore to the default values. So if you made a mistake, you can always go back to the default values by clicking on the link. The next one says Load a previous session. If you got a previous session, that session will load up. And if you like your parameters, you could always save it. The last option in the sessions box says view the triggered rainfall events. Now this will take you to the list of events that are above the trigger value. Let's click on it. You will see 2 rows of blue bands, and this means that this rainfall triggered a debris and mud flow event. The columns in the table shows the date and time of the triggered events. Bear in mind that the time shown is the time that the event ended. Next is trigger, which is the value of the accumulated rainfall event. So you'll notice that the triggered rainfall values here is greater than the triggered value that you entered earlier. Next is maximum rain, which is the highest intensity rain per hour for that particular event. The next column indicates the next hour. This is the value of the intensity of the rainfall of the next hour for that particular event. Here we see RH2M. That is actually the sum of the 2 rainfall values, maximum rain and the next hour. These 2 values here will show the type of rain, whether it's just peaking or whether that's just it, or whether it's heavy rain or the kind of rain that sustains into the next hour. If the values are close to each other, that means it's intense rain. Let's look at March 20th at 7 o'clock. The maximum rain is 57.1. However, at the next hour, it's basically 0 rain. So by this we know that it's not a sustaining rain. The working rain column here is the calculated working rain as explained earlier. And the last column is the duration of that event. Now if you click on any of the top of the column, it will sort the next hour from high to low. So you'll see that the highest is 68 and it goes down until 8. Let's pick a rain on December 24th at 4 a.m. Let's take a look at the sessions box, and you will see a single link that says view occurred events. Let's click on that. Now it will show all the recorded debris and mud flow in Cameron Highlands. There's the time and date and remarks for the events. You'll see 2 banded rows. These 2 events was triggered by the rainfall events from the blue bands on the previous page. Let's go back to the events page and take a closer look at one of these values here, December 24th at 4 o'clock. It goes to the details of that particular date. Here you'll see 4 graphs. The first graph is the hourly rain for that event. The second graph is the 24-hour accumulated rainfall, and the third one is the accumulated event rainfall. The last one is the working rain, which is how much moisture is in the ground. If you feel that this rainfall has triggered an event and you want to make it an occurrence event, click on the link in the session box called Make This an Occurrence Event. So now you get an orange band, and this band is your occurred event. This can get tricky, so pay attention now. So this is your definition of an occurred event. You can add this as permanent and it will turn blue. To do this, click on Add the User Selection Permanently link. Now you'll see the model again, but this time with the third red dot, and it's way below the critical line, so it may not have caused a debris flow. So let's go back to the list of triggered events. Click on the orange band again and make this a non-occurrence event. Okay, now let's take a look at October 16th at 11 p.m. Let's make this an occurrence event. It's 98.3 working rain, and I make this an occurrence rain. Basically, you have to go back and forth to define your occurrence events. Then you can define your line well. One thing I'd like to point out is that this red dot below the critical event could be an event not associated with your rainfall station. It could be several kilometers away and it was picked up perhaps by another rainfall station. You may want to use another rainfall station to check out your model, meaning that you have to balance your model against all other rainfall stations. So let's say you're happy with it, and now it's time to simulate your model. Okay, now let's simulate your model by clicking on Forecast. It will show you what rain you want to simulate against your model. This is a design rain based on an actual rain from the station you selected. And in the session box are two parameters that you may want to change. The first parameter is a 24-hour rain trigger. If you choose a value lower than that, you'll get more rain to choose from, but with less intensity. And then you choose which rain you want. Let's choose November 6, 2014. The squiggly line is the actual rain that occurred on the date you selected, and it's superimposed onto your model that you developed. Below the chart is the hourly rainfall for that particular event. Let's choose another rain, November 19th. As you can see, it doesn't even go to the critical line. What it means is that the rain you selected did not trigger any events. You can choose any of the rainfall events against your model. You may want to simulate the other rainfall events and see how it behaves against your model. Using this application, you can visually define your debris and mud flow model by correlating rainfall events and any occurrence events. Remember that you have to balance your model with the other rainfall data from the other Cameron Highlands rainfall stations. Good luck with your model. If you require any more information, feel free to contact the person in charge as given in the contacts page. And happy modeling!